Project K Forecast and Analyze Cardiovascular Disease under the guidance of T. Manusha ma'am, Assistant Professor. And I'm the team leader of this project, and our team members are Lokesh, Kirtana, Rani, Swapna, and Yanishwari.
It is to forecast and analyze cardiovascular disease. Cardiovascular disease is quickly becoming a primary case of mortality. Currently, it is incredibly difficult to forecast cardiovascular disease in the field of clinical data analysis because all forecasts are created by hand. It takes longer for end users to notice abnormalities. As a result, I was motivated to develop the proposed application to predict heart disease using machine learning. Currently, machine learning is beneficial in producing predictions from the massive amount of data generated by healthcare industries, hence improving prediction accurate of cardiovascular sickness. Here we identify which algorithm is best for efficient cardiovascular disease prediction by running repeated experiments on various machine learning algorithms.
Coming to our project existing system, there is no different approaches to employ data mining algorithm to anticipate heart illness. It takes longer to find the core cause of cardiac issues. There is no primitive measures available due to the late forecast. Heart disease cannot be predicted in time. There is no way to detect cardiac issues using machine learning and data mining approaches. Coming to our project proposal system. In this proposal system, we use several machine learning algorithms classifications to forecast and analyze cardiovascular disease. Using data mining techniques, accelerators, and increase sickness prediction accuracy. It uses machine learning approach for classifying the each and every factor very accurately for diagnosis of heart disease. Finding
Coming to the methodology, the front end of the application take Google Collaboration as the back-end database and UCI heart patients records as dataset. Here we can using Python as a programming language to implement the current application. The application is mainly divided into 4 modules. There are first one, implement impact necessary libraries. Second one, loaded dataset module. Third one, data preprocessor. Fourth one, trained the module using random forest and decision tree. Fifth one, find the performance of ML algorithms.
Coming to the project architecture is, first we have to take datasets of the patients regarding that project. Then we have to select attributes from the datasets. After that it moves to pre-processes of the data that removes commas, dots and unnecessary data from the datasets. After that we apply classification techniques of the data mining. There are apply several machine learning algorithms. After each and every algorithm is applied, it predicts disease and prediction with the accuracy measure.
In this project, we have used some of the machine learning algorithms. Those are logistic regressions, naive Bayes, K nearest neighbor, decision tree, random forest, XGBoost, and support vector machine. Now I am going to explain about random forest algorithm. Random forest algorithm is an assemble machine learning algorithm that builds multiple decision trees and combines their prediction. Each tree in the forest is built using a random subset of the training data with a random subset of the features selected at each split. Prediction is made by aggregating the prediction of all trees. Example, by taking the average or majority vote. This process results in the reduced overfitting and improved overall accuracy compared to a single decision tree. Secondly, now I am going to explain briefly about decision tree algorithm. A decision tree algorithm is a non-parametric supervised learning algorithm which is utilized for both classification and regression tasks. It has a hierarchical tree structure which consists of root nodes, branch, internal nodes and leaf nodes.
Now I am going to explain the code regarding cardiovascular disease prediction. From this I am going to explain in Google Colab. First we import necessary files using UCI datasets. Next import the necessary libraries like NumPy. After importing the necessary libraries like seaborn number, pair plot, extra related to the machine learning, these help in computational works and displaying the graphs in our project. Next we use heart1 CSV file, which is the dataset of the project, to read the dataset. Next for the confirmation of those related to the dataset. Totally we have 14 attributes in our dataset. A dataset contains 1025 tuples. So we are printing the data types of that 14 attributes. All the attributes are either of the type integer or float. Now I will explain all the 14 attributes present in our dataset. The dataset contains mainly 14 attributes which include age, sex, chest pain, which is categorized into 4 types, which is typically typical, ignoratypical, angina, non-angina pain and assembly pain. Next, resting blood pressure, cholesterol, fasting blood pressure, resting electrography results. Next, maximum heart rate exercise, injured, angina, old peak, slope and other attributes like CA and target. After all the attributes, we next find the mean, median, mode of the attributes, which include maximum, average and the lower part of the attributes. After getting all the attributes, then we next familiarize with the pair plot, which includes all the attributes, 14 attributes and comparison of all the 14 attributes with one another. Here we have two graphs related to the 14 attributes with one another. Next we analyze the data using pair plot, but now we specifically target these 6 attributes which includes male and female. After getting all the graphs, next we have a target value comes which includes 1 and 0. One has 526 doubles and 0 has 499 doubles. Next week analyze the problem using the patient having heart problems and then the having thin
without having.
Next we can analyze the problem using the patient having heart problems and not having the heart problems. Then we use bar plot function to plot the attributes like chest pain, which is chest pain, next blood pressure and then the electrographic results. After getting all this data and analyzing the data, which then next train and split the data into extreme and wide train. After training, after splitting this data, with then next fit the data into the model. This model gives us the confusion matrix and accuracy score of all the trained data using algorithm like novels, support vector mission, nearest neighbor, decision tree, random forest, XGBoost and neural networks. After getting all these confusion matrix with an analyze this confusion matrix F1 score precision using. So now here we have all the confusion matrix of all the algorithms, logistic regression, k nearest neighbor, random forest and all the algorithms. After analyzing and getting the confusion matrix and accuracies, with the next use to model the project which includes algorithms used in this project. Here we can see that the random forest and decision tree have the maximum accuracy for our project, which is random forest for this project because the number of permutations and combinations used in random forest are far more better than decision tree. So finally I conclude that the random forest algorithm is best algorithm for our project. Thank you.